This video explains top and bottom captured glass, which is also known as butt-jointed glazing, mall front glass, all glass storefronts and entrances. The Construction Specifications Institute has designated 084126 as the code to categorize work of this nature. It's characterized by relatively thick pieces of glass that are structurally strong enough to span vertical spaces, which means that you don't have to have metal framing to support it. It's strong enough just by itself. And so as a consequence of that, it's used regularly in malls and storefronts, offices where you want to have a nice clear open view of what's inside, or if you are inside, then what's outside. So what are the building code requirements for top and bottom captured glass? Of course, we have life safety requirements. Glass can break, and when it does, it's very sharp. It can cause cuts that are even fatal. So it's very important that any installation be designed in a way that it's safe. We're also concerned about the safety of our workers, the people who are handling and installing this glass. Very often these glass panels are quite large. Our customers want to have a nice clear wide open storefront, and you have to have a large panel of glass in order to do that. So what we want to do is we want to only use tempered glass for this type of application. Tempered glass is 4 times stronger than annealed glass. When tempered glass breaks, it's going to break into relatively small pieces. Now that can still cause severe injuries, but the thinking is that if the glass breaks into smaller, littler pieces, that those small pieces will be less likely to fatally impale or otherwise cause an injury to the same degree of severity as would a larger, jagged shard of glass. Moving on from life safety, there are 2 codes of interest to us with respect to this type of work. Building Code Section 2403.4 deals with interior glazed areas, and it requires the differential deflection of 2 adjacent unsupported glass edges shall not be greater than the thickness of the panels when a force of 50 pounds per linear foot is applied horizontally to one panel at any point up to 42 inches above the walking surface. And the second code of interest is 1607.14, which requires that interior walls and partitions exceeding 6 feet in height shall have adequate strength and stiffness to resist the loads to which they are subjected, but not less than a horizontal load of 5 pounds per square foot. That type of deflection, the bending of glass when you apply that horizontal pressure to it, it can cause the glass to separate in such a way that it can trap a finger. And that's not what we want. We don't want to create a hazardous condition. In this video, all of the glass panels are connected to each other, and so they're all deflecting together. It's important to recognize that the 2 code sections that we just reviewed govern the thickness of glass that can be used to achieve any given span. Thicker glass is more stiff than thinner glass. As the height of an opening increases, we need to use thicker glass to span that opening while limiting deflection. When panels are connected to each other so that they can't deflect beyond adjacent panels, then sometimes we can use a thinner glass in that application. Now you might be wondering, how do we know which thickness of glass to use? But there's another interesting question. How thick is glass? ASTM 1036 identifies the acceptable range of thickness for half-inch glass is 0.469 inches to 0.531 inches. That's a range of 62 thousandths of an inch, which is almost fully a 16th. So it can be plus a 32nd or minus a 32nd. That's not what we expected. But when you consider that the manufacturing process involves cooling a molten liquid, maybe we can give the manufacturers a little bit of latitude on the exact thickness. How do we know which thickness of glass to use? The National Glass Association published Engineering Standards Manual version 2019, and they addressed this issue with recommendations specific to code sections 1607.14 and 2403.4. What's interesting is that at 5 pounds a square foot, as required by 1607.14, the total force on the glass is equal to 50 pounds when the glass span is 10 feet tall. And that's the same amount of force specified by 2403.4. Although the distribution of forces is different, the result is similar in terms of the required thickness of glass. Now, when the panels are not linked together, the glass has to be thicker in order to limit the deflection. However, when the panels are linked together, we're able to use a slightly thinner glass. When it comes to being competitive in the construction industry, it's very important that we identify the means by which we can provide the best value to the building owner. In the case of glass, being that it's a transparent material, aesthetic differences between half-inch and thicker or thinner glasses are difficult to discern when it's in the finished state, because you can only observe those differences when you view the material edge on. We already talked about the tolerance required for the thickness of glass material, but there are other tolerances that need to be considered as well. Perhaps the most important of these is the cut size of the glass material itself. ASTM 1048 identifies that the cut size tolerance for half-inch glass is 1/8 of an inch. This means regardless of what size glass we order, when we order half-inch glass, we need to be able to use the size that we're ordering. We need to be able to use a piece of glass that's 1/8 of an inch smaller than the size that we're ordering. And we need to be able to use a piece of glass that's 1/8 of an inch bigger than the size that we're ordering. The cut size tolerance for thin glass is less than it is for thicker glass. Our ability to control the impact that these edge conditions have on the overall size of the glass diminishes as the thickness of glass increases. This is because when we cut glass, it doesn't always break in such a way that the edge is perfectly perpendicular to the surface of the glass. It can have flakes, chips, bevels, flares. These different edge conditions are expected when you're working with glass. That's why we need to anticipate allowing the proper tolerance for the size of the glass. The same 1/8 inch tolerance applies to the difference between diagonal measurements taken from a rectangular panel. Bow and warp are inherent characteristics of heat-treated glass. Each of these characteristics describes a different type of curvature. The bowed condition is associated with the type of curvature which leaves the edges of glass parallel to one another, whereas the warped condition is associated with a twisting that skews the edges of the glass relative to one another. Bow and warp are each measured in the same way, by placing a straight edge relative to the material surface and measuring from the straight edge to the surface to quantify the amount of distortion. We're always going to expect that the glass we receive has some amount of distortion. What is important is that the framing system that will accept and support the glass can accommodate the inherent distortion. Thinner glass is allowed relatively more distortion than is thicker glass. In the case of half-inch thick glass, between 60 and 120 inches long, 2 millimeters of distortion is permissible. However, 8 millimeters of distortion is commonplace. Fabrications in glass include holes, notches, and cutouts. The locations and dimensions of fabrications also require a tolerance. In glass which is 1/2 inch thick or more, notches and cutouts shall have a 1/8 inch tolerance in their locations and their dimensions. Holes are allowed a 1/16 inch tolerance. Aluminum extrusion also has some tolerances that we need to be aware of. You start by taking a hot billet of aluminum, it's the cylindrical shape, and then you press it through a die. The die shape has the shape of the profile. It squirts out of the die quite hot in a fairly plastic state. It's grabbed by a machine that trims the extruded parts. They go down a conveyor where they get stretched, and this is why aluminum profiles are so straight. Machines will clamp on either end of the profiles and then stretch the material about 3%. And it's that stretching that straightens the aluminum material. After they're stretched, then the ends of them are trimmed. You can see the ends, they're not straight. That's where the machine grabs it to clamp it. And there you go. You have a perfect aluminum profile after that. But perfect is within tolerance. And the tolerance is 1 degree in the angle where sides meet. There can be other specifications for a particular shape, but in general, aluminum profiles are going to have a 1 degree tolerance for the angles of meeting surfaces. This is why we use rubber gaskets when we install glass in aluminum frames. The rubber gasket is what takes up the space between the glass and the metal. And again, we don't know the thickness of the glass, and we don't know exactly the thickness or the relative geometric positions of the aluminum extrusion member itself. So that's why we use rubber. Rubber is not a water seal. It's a means of taking up the space between the glass and the metal when we don't know exactly what that space is going to be. Finally, we need to recognize that blemishes are inherent to glass material as soon as it solidifies. Blemishes are defects which can be visually observed in the glass material itself, and they're classified based on the observation distance. The type and frequency of blemishes which are present in the glass material are used to determine the quality of the glass material. Q3 quality glass is used to produce windows and doors.